Hello and welcome to Manifest Maths. This is going to be a video on surds, simplifying surds. We're going to look at typical past paper questions. We'll return to this question at the end of the session. Right, we're going to jump straight in with an example then to start off with. Okay, so in this case we need to simplify the following expression. Okay, we've got an algebraic fraction. And what you'll notice is at the bottom we've got two quadratics that we need to expand. So we've got root of a plus 3 squared and root of a minus 3 squared. So the first thing we're going to do is we're going to simplify the bottom. Our top is going to remain as 24 root a. Now we're going to simplify the bottom. I'm going to do that separately over here. So you'll notice we have root of a plus 3 squared. So we're going to simplify that first. So we're going to write root a plus 3 times by root a plus 3. Multiply the first, so root a times by root a, which gives us a. Root a times by 3, which is 3 root a. And 3 times by root a, which is another 3 root a. 3 times by 3 is plus 9. We can simplify the two middle terms, which gives us 6 root a plus 9 at the end. Be careful, my a and my 9 look quite similar. Then we're going to simplify root a minus 3 squared, which is root a minus 3 times by root a minus 3. Root a times by root a, that's going to give us 8. Root a times by minus 3 is minus 3 root a. And the two middle terms gives the same, minus 3 root a. And then minus 3 times by minus 3 gives us again plus 9 at the end. Okay, that will simplify to a minus 6 root a plus 9. So what we can do now is we can substitute these two values into the original expression. So remember, this simplified to a plus 6 root a plus 9. Then we're subtracting this term. Now I'm going to put brackets around all of this. So we have a minus 6 root a plus 9. Now it's important I put brackets around those because obviously I'm subtracting all of this, so it needs to be squared first. Now the top is going to stay as 24 root a. The bottom is going to be a plus 6 root a plus 9 minus a. Then minus and the minus 6 root a becomes plus 6 root a. And then minus and the plus 9 gives us minus 9. Then lots of things simplify here. The plus 9 and the minus 9 simplify. They cancel each other out. The a and the minus a cancel out. So the top is 24 root a. The bottom is 6 root a plus 6 root a, which gives us 12 root a. Root a's cancel, and 12 goes into 24 twice, gives us an answer of 2. There's our final answer. Now you could check that answer by substituting a value for a into the expression. So for example, if you made a equal to 6, you could run that in your calculator, substitute a as being 6, and check your answer, and it'll simplify to 2. Okay, right, let's jump straight into a question then. So there's another one here for us to try. Now, there's 3 parts to this question. 1, 2, 3. I would recommend, it says, that you simplify each one. So the first one is 56 over root 2. Now, what we have here in this case is a surd at the bottom. We've got an irrational denominator. So the method for doing this is you want to rationalize that denominator. So we times it by a fraction that's equivalent to 1. Now the fraction that we're going to multiply by, which is equivalent to 1, is going to be root 2 over 2. We've selected the root 2 because there's a root 2 at the bottom. Now we multiply this gives us root 56 root 2 at the top. And then root 2 times by root 2 at the bottom gives us 2. And then we can divide the 56 by 2, which gives us 28 root 2. So this is our first term. Now the middle term is root 450. Now what we have to do here is we have to think of a square number, or the biggest square number that will go into 450. In this case, if you halve 450, you end up with 225, which is a square number. So root 450 can be written as 225 times by 2, which according to the rules of surds gives us root 225 times by root 2. The square root of 225 is 15, so that gives us 15 root 2. Now a good hint of this is, if you notice on the first term, it was in terms of root 2, so it's very likely that the middle term also is going to simplify to a root 2. Okay, you could have also done this in a few steps. So for example, you might have recognized straight away that 25 will go into 450. So you would have known, you might well have noticed that straight away. Now 25 goes into 450 18 times. That would have given us root 25 times by root 18, which gives you 5 root 18. Then you could have simplified the root 18 to 9 times by 3, which would have given you 5 root 9 root 3. Sorry, not root 3, root 2. Which would have given you 5 times by 3 times by root 2, which would also give you the 15 root 2 that we needed. Okay, so you can simplify surds in steps if you want. Now the final term, we have root 2 to the power of 7. Okay, now the best way to think about this perhaps would be to consider that we have root 2 times by root 2 7 times. Again, there is more than one way of doing this. This might seem like an arduous way of doing it. 1, 2, 3, 4, 5, 6, 7. And then to recognize that pairs of root 2 will times together to give you 2. So the first 2 will give you 2, the second 2 will give you 2, the third 2 will give you 2. The last one's on its own. 2 times 2 times 2 is 8, so that gives you 8 root 2, which is the last term simplified. Now we need to combine these terms together. So we'll have 28 root 2, which is the first term, minus 15 root 2, minus 8 root 2. 28 minus 15 is 13 root 2, minus 8 root 2 gives you an answer of 5 root 2. Simplified. Okay, so there's a few more now for you to try. I'd like you to pause the video, give these ones a go, and I'll go through the answers in the next few slides. Okay, so first question. Step number 1, we're going to simplify the first term. We've got 7 over 2 root 14. Now, what we're going to do here is rationalize the denominator, which gives you 7 over 2 root 14 times by root 14 over root 14. The top goes to 7 root 14. Root 14 times by root 14 is 14. You times that by 2, gives you 28 at the bottom. Now, 7 28 can be simplified to a quarter, so this first term goes to root 14 over 4. Okay, second term, we have root 14 over 2 cubed. So that can be written as root 14 cubed over 2 cubed. Root 14 cubed can be written as root 14 times by root 14 times by root 14. 2 cubed at the bottom is 8. The top pairs of root 14 will give you 14. The top goes to 14 root 14. And the bottom will be 8. Now we can simplify this fraction by halving top and bottom, which gives you 7 root 14 over 4. So this is our second term simplified. Then we want to combine those together. So we have root 14 over 4 plus 7 root 14 over 4, which gives us 8 root 14 over 4, which will give us an answer of 2 root 14. And this is our final answer. Okay, question 2, second one. Let's simplify the in parts again. So we've got root 12 times by root 24. Now, what it might be a good idea to do here is to simplify both individual parts first. So root 12 can be written as root of 4 times by 3, and root of 24 can be written as root of 4 times 6. So that will simplify to root 4 root 3 times by root 4 root 6, which goes to 2 root 3 times by 2 root 6. 2 times by 2 is 4. Root 3 times by root 6 is root 18. Now root 18 can be simplified further, because 9 is a square number that goes into it, which is 9 times by 2. So that gives you 4 root 9 times by root 2, which is 4 times 3 times root 2, which gives you 12 root 2. So that's our first term simplified by a long-winded way of doing it. Right, the second term, root 150 over root 3. And what we can do here is combine it as one larger surd, which is 150 over 3, which gives you root 50. 150 divided by 3 is 50. This simplifies to 25 times 2, which gives you root 25 times by root 2, which gives you 5 root 2. That's the second term simplified. Much quicker than before. Ignore that little bit of graffiti there. But the last term, we've got 36 over root 2, which we want to rationalize the denominator. So we're going to times by root 2 over root 2. That's going to give us 36 root 2 over 2, which gives us 18 root 2. That's our third term. Now we're going to combine them together. The first term was 12 root 2. We're going to add on the 5 root 2, and then take off the 18 root 2. 12 root 2 plus 5 root 2 is 17 root 2. Take away 18 root 2 is minus 1 root 2. And that's our answer. Okay, third question. Don't be put off by the b inside. So first term is 2 root 6b squared over root 2. So the first step here might well be to deal with the root at the top. So we've got 6 times by b squared, so that becomes root 6 times by root of b squared over root 2. Now root 6 is a surd, it can't be simplified, so we're going to leave it as root 6. b squared square rooted just gives us b. So we've got 2 times root 6 times by b over root 2. Next step is, we might want to write that as 2b root 6. Write the letter at the front of root 2. And then what we might want to do is we might want to times the top and bottom by root 2 to rationalize that denominator. 2b root 6 times by root 2 becomes 2b root 6 root 2 all over root 2 times by root 2, which is 2. The 2 and the 2 are going to cancel. Root 6 times by root 2 is root 12, so this becomes 6 root 12. Root 12 can be written as 4 times 3, which gives us 6 root 4 root 3. Root of 4 is 2, so 6 times 2 times root 3, which gives us 12 root... Mistakes being made here. I've missed the b out. We should have a b in front here. In fact, that is a b, isn't it? Not a 6. So we end up with 2b root 3. Sorry, my b looks like a 6. So that simplifies to 2b root 3. Our root 27, which is the middle term, goes to root of 9 times by 3, which is root 9 root 3, which gives us 3 root 3. Quite straightforward. And the last term, root of 192. We're going to shoehorn in the 3 here, because obviously we're going to simplify these. We've got root 3 and root 3 in the first two. And 192 divided by 3 gives you 64, which happens to be a square number. So this goes to root 64 root 3, which is 8 root 3. So our final answer, we end up with 2b root 3 minus 3 root 3 plus 8 root 3. Now they've all got root 3 in common, so we can factorize out root 3. And we'll have 2b minus 3 plus 8, which gives us root 3. 2b minus 3 plus 8 is plus 5. And that's our final answer. Okay, next question. Start off with the root 360. Okay, we've got 36, which we know goes in. It's a square number. So we end up with 36 times 10, which gives us root 36 times by root 10, which gives us 6 root 10 for the first term. Our middle term is root 2 times by root 5 all cubed. So the root 2 is going to remain as it is for a second, and that's being times by root 5 times root 5 times by root 5. This pair of root 5s gives us 5. So we have root 2 times 5 times root 5, which gives you 5 root 2 root 5. We can combine the root 2 and root 5 under 1/3, which gives you 5 times by root of 2 times by 5, which gives you 5 root 10. Third term, we have root 30 times by root 8 over root 6. We can do 30 times by 8, which is 240, over root 6. we could divide the two numbers then, because they're both rooted, 240 over 6, which gives you root of 40. 240 divided by 6 is 40. Root 40 can be written as root of 4 times 10, which gives you root 4 root 10, which gives you 2 root 10. All three terms are in terms of 10. So the first one, 6 root 10 minus 5 root 10 minus 2 root 10. 6 minus 5 is 1. Minus 2 gives you minus 1 root 10. So final answer is minus root 10. And the next question. So we have 4 root 3 squared, which becomes 4 root 3 times by 4 root 3. 4 times by 4 is 16. Root 3 times by root 3 is 3. So that gives us an answer of 16 times by 3, which is 48. Middle term, we have root 8 times by root 50, which gives us root of 400, which is 20. And the last term, 5 root 63 over root 7. So we're going to rationalise the denominator for this one by timesing top and bottom by root 7. So our top, this gives us 5 times root 63 times by root 7. And the bottom goes to root 7 times by 7, which is 7. Now root 63 times by root 7 is root of 441 over 7. Root of 441 is 21. So this becomes 5 times by 21 over 7. 7 goes into 21 3 times. So the top goes to 15. So our three terms are 48 minus 20 minus 15. 48 minus 20 is 28. 28 minus 15 gives an answer of 13. It's the first question that wasn't in terms of surds. I'm actually simplified to whole numbers. Okay, right, so this is the questions on the front page. I'd like you to pause the video and give this one a try yourself, and then I will go through the solution. So hopefully you've had a chance to try this question. Okay, we're going to simplify each term individually. First term is 5 root 48. So we're looking for square numbers that go into 48. The most obvious being 4. Now 4 goes into 48, but if 4 goes in, it might be worth considering if 16 does. 16 goes into 48 3 times, so we have 16 times by 3, which gives you 5 times by root 16 times by root 3, which gives 5 times 4 times by root 3, which gives you 20 root 3 for your first term. Now the second term, there is a lot going on. We've got 2 plus 5 root 3 over 5 plus 3 root 3. Now we need to rationalise the denominator for this. So what we're going to do is we're going to times it by 5 minus 3 root 3 over 5 minus 3 root 3. Now, if you need to practice rationalise the denominator when there's two terms at the bottom, then watch the video on that, which is the previous video to this one. But the key is that you change that plus sign to a minus, as you can see here. Now, when we execute this multiplication, we use double bracket expansion. So you could think of having brackets around both those terms. 2 times by 5 is 10. So this is the top being simplified. 2 times by minus 3 root 5 is minus 6 root 5. Sorry, root 3. 5 root 3 times by 5 is plus 25 root 3. And the last, we've got a plus times by a minus, which is a minus quantity. 5 times by 3 is 15. And root 3 times by 3, root 3 is 3. So it's 5 times by 15 times by 3. But it's simplifying for the top. Actually, let's leave that as the top for a second, and let's simplify the bottom first. 5 times by 5 is 25. 5 times by minus 3 root 3 is minus 15 root 3. 3 times by 3 root 3 times by 5 is plus 15 root 3. And then plus times by minus is a minus. 3 times by 3 is 9. Root 3 times by root 3 is 3. Now what you notice here is the two middle terms at the bottom cancel. That's a symptom of having changed the signs. Let's simplify the top. We've got 10, and at the end we've got 15 times by 3, which is 45. 10 minus 45 gives us minus 35. The top, minus 6 root 3 plus 25 root 3. So that's going to give us 19 root 3. The bottom is going to be 25 minus 27, which is minus 2. Now, we don't like to have a minus number at the bottom, so what we can do here is we can times everything by top and bottom by minus 1, which will change the top to 35 minus 19 root 3 over 2. So that's our middle term. Right, the final term, I'm going to simplify it up in the box up here so that I don't run out of space. But we've got 2 root 3 cubed, which is 2 root 3 times by 2 root 3 times by 2 root 3. 2 times 2 times 2 is 8. Root 3 times by root 3 is 3. And then we've got a root 3 on its own. 8 times by 3 is 24, so this is simplified to 24 root 3. So we've got our 3 terms, okay? So I'm going to write those out here. The first term was 20 root 3. Second term was this 35 minus 19 root 3. So plus 35 minus 19 root 3 over 2. And then the last term was 24 root 3. So minus 24 root 3. Now we need to simplify this further. Now you notice the middle term is over 2. So we might want to write the first and last term as a fraction over 2. So if we double the 20 root 3, that becomes 40 root 3 over 2. The middle term we can leave as 35 minus 19 root 3 over 2. And the last term would be minus 48 root 3 over 2. Now we have all of the terms over 2, so we can combine them as one single fraction. So that becomes 40 root 3 plus 35 minus 19 root 3 minus 48 root 3 all over 2. And the final step, 40 root 3 minus 19 root 3 is 21 root 3. And 21 gives us a total of minus 27 root 3. We've got the plus 35, so on and so on, and then we've got the 2 at the bottom. And this is our final answer. Okay, so that concludes the video on simplifying surds. This skill is an important one for Unit 1 Maths. You might want to revisit the video on rationalising the denominator, which was the middle term here, because that got quite messy. It was this part. If you feel need to practice any further, please look at that other video.